Hello friends, welcome to my YouTube channel, and today I am going to discuss about the DOL starting procedure of freshwater hydrophore pump. This freshwater hydrophore pump is used to supply the fresh water to all the taps for the freshwater consumption, and I will tell you the exact panel wiring, 444 volt panel wiring for starting this motor. You can see this is the panel wiring diagram taken from the manual. This is the motor, the three-phase induction motor. We are supplying 440 volt 60 hertz to this motor, and these are all the components. You can see MCB over here. This is a step-down transformer. This is the light which will glow once the induction motor starts, and this is the stop switch. This is the start switch. This is also a stop switch. This is the start switch. This is the panel switch which we get in the ECR, and this is the remote switch. It is provided at local to the pump. This is the thermal relay. This is the magnetic contactor. This is the coil. This is the anode contact of magnetic contactor. This is the manual auto selector switch. This is the pressure switch. This is the DENFOS differential pressure switch, and I will show you on the panel all these components one by one. Now you see, this is the panel, 440 volt motor control panel. You can see all the motor operating switch over here and the MCB switches. Now this is the freshwater hydrophore pump, 1.4 kilowatt. This is the ammeter to show how much current it is drawing when started. This is the start, and this is the stop switch. This is the manual and auto selector switch, and this is its MCB. Now I will open the panel and show you one by one all the components. Now see, this is the motor control panel, how it looks from inside. Now, before working on this 440 volt panel, make sure the supply is not there, because 440 volt shock can be fatal. Now, you see, this is the ammeter. This is the start switch with the green light attached. This is the stop switch, which is a NC switch, and this is the selector switch, auto and manual selector switch. Now this is the magnetic contactor of this freshwater hydrophore pump, and this is the thermal overload relay. You can see the wiring. This is the reset button. Once the motor has been off due to overcurrent, we cannot start the motor until and unless we press this reset button. And this is the timer with which we can adjust the time at what overload the motor should trip. These are the main contacts, and these are the add-on contacts. 23 and 13 are the add-on contacts. This is the thermal overload relay NC contacts, 95 and 96, and this is the NO contact, 98 and 97. And this is its MCB. It is getting supply from the bus bar. The bus bar is behind this MCB, and from below it is going to the contactor. This is the panel wiring which I have made for practical understanding, and the terminals are originating from all the electrical switches and the contactors and relay, exactly what is on the panel. Okay. So this wiring is exactly similar to the panel wiring. This I have made you for the practical understanding. Now this is the bus bar. You can see from the bus bar 3 phases is coming to the MCB, and this is the manual switch. Once we close it, the supply will come to the contactor. Okay. Now now 2 phases. We take 2 phase and take this 2 phase to the step down transformer. Okay. And from the step down transformer we are getting 2 voltage supply, One is 110 volt and other is 15 volt. Now, you see, this is the power circuit and this is the control circuit. But this power circuit operation is controlled by this control circuit. Now, I will tell you one by one how the system is working. Suppose we want to run this pump in manual mode. Means this pressure switch is bypassed. Okay. So in the manual mode, the manual switch is like in this position. You see here, once the switch is on this side, it is operating as manual, and once the switch is this side, it will turn to auto, and this pressure switch will come into action. Now in the manual mode, you can see we are taking this one phase from the step down transformer. You see this phase is coming, going to the remote switch, which is a stop NC switch. And again, as this is NC contact, the phase will come from here to here, and again from here we are giving it to the start switch, and again from here we are giving it to the panel switch. This is the ECR panel switch. See, number 2 and number 4. As this is NC contact, the phase will come from here to here. Now from here you can see we are taking this phase to this manual auto switch. See, as this switch is in the manual mode, the phase 4 will come from here to here and will go via this, you can see, to the ECR start switch. And see, again from this phase is going to the contactor NO contact. And as this is a NO switch, the phase will not go from here to here until unless we press this switch. Now you see how it is operating in manual mode. Suppose in the ECR we are pressing this start switch. Once we press this start switch, the phase will come from here to here. Now the phase is going, see how the phase is going. The phase is going over here to the contactor NO terminal, and again it is coming to the thermal relay, and via this, as this is close contact, NC contact, it will go to the contactor coil. Now once the contactor coil is energized, all the NO contacts will become NC. Okay. Now once this NO contacts become NC, the supply from here will come to here. See, as this thermal overload relay is already closed, the supply will go directly to the motor and the motor will run. But once we remove our hands from this start switch, the phase will not go to here and the coil will de-energize and the motor will stop. Now we have to provide, we need to bypass this start switch so that the coil remain energized once we remove the finger from the start switch. Okay. So for that we provide an additional add-on contact. This is the add-on contact. Now see how we are providing this bypass. See, it is when we are pressing the start switch, it is coming over here, going to thermal relay and is energizing the coil. Now see, this 4 is coming here. From here, this phase 4 is coming here, and once the contactor coil is closed, this phase is going via this and energizing the coil. Okay. Now in this way, even we remove the finger from this start switch, the coil will remain energized and the induction motor will keep running. Now we want to run the induction motor in auto mode. Now when we are pressing the switch to this auto mode, this differential pressure switch will come into action. Now see what is happening. When we turn the selector switch to auto, this will shift over here and this 4 and 4 will break. Okay. Now see how it is going to start. When we are pressing this in auto, this differential pressure switch will come into action. See, this 4 is coming over here and we are taking this 4 to this side also, and once this is over here, this phase 4 is coming via this 11 to the differential pressure switch. This is the common of the differential pressure switch, and this is the NC contact and this is the NO contact. But with NC contact we are not taking any wire. With the NO contact we are taking the wire. This wire is going to the thermal overload relay and from here it is energizing the coil. Now I will show you how it is working. Now once the water pressure has reached, suppose the cut-in is at 3.5 bar and cut-off is at 2.5 bar. Okay. Now when the cut-off pressure is 2.5 bar, okay, when the pressure is 2.5 bar, this will operate, and this NC contact will become NO. This NC contact will become NO, and this NO contact will become NC. This switch will shift over here. The phase will come from here to here, and see, the phase will go via this NC contact of the thermal overload relay and will energize the coil. The neutral is already given via this neutral point, and the coil will energize. Now the interesting thing to look in this is, once we are running this pump in auto mode, even if we press the start button, this panel start button, the motor will not start. I will show you how this is working. Suppose this cut-in pressure has reached 2.5 bar, this switch has changed over to this, and the phase 4 is coming via this 11, going via this thermal relay and energize the coil. Now until unless 3.5 bar is reached, this will remain closed. Now during this time, even if we press the start button or when it is running in auto mode, the pump will not start. See what is happening. Now it is in auto mode, this switch is over here. The phase 4, see the phase 4 coming from here to here and going to this for providing the holding for this coil is not available, because this switch has been shifted to this position. So this 4, which is providing the holding for this coil, is not available when the selector switch is in auto mode. So when we are running the pump in auto mode, even if we press the start switch in the ECR panel, the motor will not start. Now I will tell you the function of this thermal overload relay. Suppose there has been a problem in the motor. Suppose the bearing has jammed or some insulation fault has happened and motor is trying to draw more current. So what will happen? This thermal overload relay will sense the current, and once it reaches a specific value, depending upon the time adjustment, this all NC contact will become NO. Okay. Once this contact opens up, the current which is going to energize this coil breaks, and once this coil is de-energized, all these NC contacts will become NO and the motor will stop. So until and unless we press the reset button of this thermal overload relay, even if we press the start button, the motor will not run. Okay, because the current which is going by this NC terminal of thermal overload relay to energize the contactor coil is not going, because this has become NO, this has opened. So we have to press the reset button and reset this thermal overload relay. It will come to this position after pressing the reset button, and then only we can run this pump. Now I will tell you what happens when the motor is running and we press the stop button. So pressing this stop button should stop the motor. So the action that will happen is, suppose the motor is running and we press the stop button. So once we press the stop button, the phase will not come from here to here, as this will become NO. See, the phase from 2 to 4 will not go, and the 4 in manual running, and the 4 which is going to for holding the contactor coil, is not there. So the coil will de-energize. Once this is de-energized, all the NC contacts will become NO, and the motor will stop running. So when we are pressing the stop button, the motor is stopping. Now I will tell you how this light is glowing when the motor is turning on. Now when the motor turns on, means this contactor coil is energized and all the NO contacts is NC. Then you see, this is the 50 volt supply taken from the transformer. It is going via this, and as this contact has become NC, the phase will come from here to here, and see, via this we are supplying this light. The neutral is already supplied via this neutral point, See, the neutral is given to this light and this coil. So once the contactor coil is energized and this has become NC contact, the phase will come and go to energize the light. If you have enjoyed the video and if you like my video, please like, share, comment and subscribe to my channel. It is Rohit C Vlogs. Thanks. Have a nice day.